So 3D cost function, we want to find the minimum or maximum. That's what we usually want to do, because we're gonna have the error graph, then we're gonna find the minimum error. Or if we want to solve for a certain situation, we want to calculate for the maximum chance. So we usually find the mean or max. Then let's go back to our partial, so G. So let's go back to the vector. I can use this one as a partial f, partial x, fixed one, dot product, flexible one. So I can say the first one is fixed quantity. Again, I'm saying that. Then second one is constant magnitude. In the vector union, we learned vector u dot product vector v, we can rewrite as magnitude of vector u times magnitude of vector v times cosine theta to find the angle. Is that right? Then magnitude is always positive. Then fixed values. Then depends on the cosine value, because cosine is between -1 and 1. We can find the max and we can find the mean. When cosine is 1, which angle? Yeah, 0 angle, 0 degrees. When we go to the 0 degrees, that means we are solving for max value. When we go to the -1, what angle? Yeah, when we go to the 180 degrees, pi, yeah, that means we are going to go to the minimum. So minimize or maximize. Now let's rewrite this part. So this one I can say magnitude of the vector, first vector, times the magnitude of the second vector, times cosine theta. So I can have some note here to maximize. Take angle goes toward to 0 degrees because cosine 0 is 1. Then to minimize this value, take angle goes towards 180 degree because cosine 180 degree is minimum value -1. So now we know how to decide the direction. Then let's simplify this one again by using another wording, gradient vector. We call that as a gradient vector. If we have fixed quantity, then we are going to have a constant magnitude xy values. Then if we know the direction, so I can say the definition of this gradient vector as given function g with the function of x and y, we are going to say the fixed quantity, the partial vector as nobla f. So fixed one, we are going to give the new name. So we don't have to write the partial respect x, the partial respect y all the time. We are going to just call this one as nobla f. So looks like inverse delta, but the new name is nobla. This one represents a partial. Then we also call it as a partial f. That means all the partials of this function f. Then I can say that directional derivative of f with a specific direction. So constant magnitude becomes my specific direction. I'm going to try different value each time to go to my goal direction. So a specific direction vector v is, so this one is vector v, and this one is now becomes nobla f. nobula f dot product vector v. So this is still dot product. Let's think about example 5. I want to get the local or absolute minima. That means, minima means slope is 0. That means change should be 0. Derivative should be 0. How can I make the 0? If magnitude becomes 0, that is 0. If I can make one of the vector 0 vector, that is 0. What x, what y value makes this one as 0. So we can get the fixed quantity. Then when we plug in the xy value, if it becomes 0 vector, that means I can find the minima. So partial, I just need to look at the x, so that is simple. For the second partial, respect to y, I just need to look at the y, just so that is also simple. Then my goal is nobula f as 0 vector. That's the goal. To make minimum or maximum, slope should be 0. I can say 2x, 2y minus 2 vector is 0 vector means 0 and 0. All the quantity should be 0. So you can solve 2x is 0, that means x is 0. 2y minus 2 is 0, that means y is 1. So the bottom one, what it talk about is directional derivative nobula f, nobula function with x and y, and dot product directional vector v. What we can say is x and y will be our starting position, then vector v as our moving direction. So to maximize, we go to the right direction. So go in direction of regular nobula f. If we want to minimize, so go in direction of negative nobula f. So we can say that as an example, when we have a function as 2x plus 3y, nobula f will be vector with 2 and 3. So I can say go in direction of 2, 3 to maximize, or negative 2, negative 3 to minimize.